Hello viewers, welcome again to today's lesson. This is the Solution Space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want us to continue with the vectors that I started with you in the previous videos. In the previous videos, we started learning about vectors, and we've already treated many subtopics on the vectors already in the previous videos. And the last thing that we looked at on the vectors is the vector law that governs a parallelogram, which we've done a detailed explanation on it, and also we've solved some examples on it as well in the previous videos, and I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to proceed and handle another aspect of the vectors, and that is we finding the direction or bearing of a given vector. As you can see from the board, I've written direction or bearing of a vector on the board. Okay, so this is what I want to teach you in this video, and you can also see that I have an example on the board that I want to solve with you. But before we proceed and solve the example that I have on the board, I'm going to do a brief explanation on the direction or bearing of a vector, so that when you gain the understanding, we can proceed and solve the example one that I have on the board together. Okay, so let's start with the direction of a vector. Okay, so now when we speak of the direction of a vector, in simple terms, it refers to the measure of the angle the vector makes with a horizontal line. Okay, I'm going to repeat it one more time. I'm saying that when we speak of the direction of any given vector, in simple terms, it just refers to the measure of the angle that the vector makes with a horizontal line. Okay, and that is what gives the direction of a vector. Okay, now for us to be able to find that measure of angle, then it will lead us to the bearing of a vector, because the means to obtain that measure of angle is by bearing or through bearing. I hope the explanation is clear enough up to this point. Don't forget the definition that I gave on the direction of a vector. I said that the direction of any given vector simply refers to the measure of the angle that the vector makes with a horizontal line. Okay, so when we want to find that measure of angle, then the means to obtain that angle is by bearing. Okay, so we are going to use the knowledge on bearing to be able to obtain that measure of angle. Okay, and so when we speak of bearing, bearing just gives direction in terms of an angle. Okay, and you know that we cannot speak of bearing without talking about the cardinal point. Anytime we talk about bearing, then the cardinal point also comes into play. So I'm going to draw the cardinal point on the board, and I'm going to use it to do a further explanation on the bearing. Okay, so let's go ahead and let me draw the cardinal point on the board so that we can do a further explanation on it. Okay, so I have my north, south, west, and east. Okay, so this is my cardinal point, and you can all agree with me that there is an angle of 90 degrees which is being formed at each quadrant on the cardinal point. I hope you can all agree with me on that. So when we go to each quadrant on the cardinal point, there's an angle of 90 degrees which is being formed there. So when we pick this quadrant, there's a 90 degrees angle which is being formed here. So we have a 90 degrees angle forming here. We come to this quadrant also, we have a 90 degrees angle being formed here. We come to this quadrant as well, there's a 90 degrees angle forming here, and also there's a 90 degrees angle forming here as well. So each quadrant on the cardinal point forms or gives an angle of 90 degrees. I hope you understand and you agree with me up to this point. Okay, so now another thing that you are supposed to know about bearing is that when you are reading any angle, okay, on a cardinal point, or when you are reading any bearing, you always need to start from the north and you read in the clockwise direction. I'm going to repeat it one more time because that statement is very important. I'm saying that anytime you are reading, when it comes to bearing, anytime you are reading an angle, okay, on a cardinal point like this, okay, what you need to do is that you always start reading from the north and you read in the clockwise direction, okay, which is very important. So keep that in mind. Okay, so the key things here are you always start reading from the north and you read in the clockwise direction. So when it comes to bearing, you always start reading from the north in the clockwise direction. Okay, so this is the north, okay, so if I start reading from here, then of course here will be 0 degrees, okay, because this is the starting point where you start reading from. Always you start reading from the north. So assuming I start reading from here up to this point, so let's read from here up to this point. I hope you can all agree with me that if I read from the north here up to the east, okay, which is this point, it will give me a 90 degrees angle, okay, because the starting point is the north, which is 0 degrees. I read up to the point E, then it will give me 90 degrees because the angle which is being formed at this quadrant is 90 degrees. Okay, so reading from the north here up to the point here is going to be 90 degrees. Okay, now again, let's say that I'm reading from the north here up to the south, okay, the point S, which is the south. So I read from here and up to the south. You can all agree with me that I'm going to get an angle of 180 degrees when I read from the north up to the south. Why? Because there's a 90 degrees at this quadrant and also there's 90 degrees at this quadrant. So reading from the north up to the south is going to be 90 degrees, which is here, plus the 90 degrees, which is here, which will give me 180 degrees, okay? And I hope you agree with me and you understand up to this point. Okay, so now let's continue. Assuming that I want to read again from the north up to the west, this point W. Okay, so I read from here up to the west. So I'll continue up to the west. And that is going to give me 270 degrees. Why? Because it's going to be the 90 here plus the 90 here plus the 90 here. So that will give me 270 degrees. That is when I read from the north up to the west here. I hope the explanation is clear enough up to this point. Okay, let's proceed further. So let's read from the north again up to the same point, which is the north. We will move in the clockwise direction up to the north again. So we'll pass through all these points and we'll continue up to the north again. Okay, so I hope you can all agree with me that it will give a 360 degrees. Okay, that is when we start from the north here and read back to the north again. We are going to get 360 degrees because it's going to be the 90 degrees here plus the 90 degrees here plus the 90 degrees here plus the 90 degrees here, which will give me 360 degrees. That is, if we read from the north up to the north again. I hope the explanation is clear enough up to this point. Okay, so keep in mind that when you are reading, when it comes to the bearing, when you are reading on a cardinal point, you always start reading from the north in the clockwise direction. Okay, and also you need to take note that bearing are always written in 3 figures. Okay, always we write bearing in 3 figures. So assuming I read a particular bearing and I'm getting, let's say, 58 degrees, because bearing are always written in 3 figures, you have to start with a 0 so that you can get the 3 figures which you need. Bearing is always written in 3 figures or in 3 digits. So instead of writing 58 degrees, I'll write 058 degrees. Okay, that's how to go about it. But in the case where the value is already in 3 digits or in 3 figures, that's why you don't have to do anything about it again. So assuming, let's say, I read a particular bearing and I'm getting, let's say, 160 degrees. This is already in 3 figures, so I don't have to do anything about it again. But if I get, let's say, 21 degrees, then I have to write it as 021 degrees. I hope the explanation is clear enough up to this point. Okay, so I'm going to clean this so that we can proceed and do a further explanation. Okay, now the first question that I have on the board, example 1, it says find the direction of the vector AB equals to 3, 4. Okay, so I'm going to use that as an example to explain it further to you. Okay, so what you need to do is that first of all, we are going to plot this component of the vector AB on a cardinal point. Okay, and I'm going to show you. It's very simple. Okay, so I'm using the first example to explain further. Find the direction of the vector AB. So I'm going to clean this side. Please keep this explanation in mind because we are going to apply that knowledge going forward. Okay, so let me clean this side and let's continue. So I have to draw my cardinal point again. Okay, so just draw your cardinal point again and label it nicely. So this is the north, this is the west, this is the east, and this is the south. Okay, now you can all agree with me that the vector AB, let me write the vector AB down. So I have the vector AB equals to 3, 4. These are the components of the vector AB which I've explained in the previous videos. Okay, and you can all agree with me that the top value refers to the x component and the down value refers to the y component. Okay, so anytime you have a vector like this, the top value is the x component, the down value is the y component. So we are going to draw this on the cardinal point. Okay, so we are going to consider the cardinal point as our Cartesian plane. You know, the Cartesian plane, we have the y-axis, we have the x-axis. So the vertical line is always the y-axis and the horizontal line is always the x-axis. Okay, I hope you know that. So we are going to consider this vertical line as the y-axis. Okay, so this is going to be my positive y-axis, this is going to be my negative y-axis. Okay, then we are going to consider this horizontal line also as our x-axis. So this is going to be my negative x-axis and this is going to be my positive x-axis. Okay, you know about the Cartesian plane. Okay, so you consider the cardinal point, the vertical line, as the y-axis and the horizontal line as the x-axis because we need to plot this component of the vector AB on the Cartesian plane. Okay, I hope the explanation is clear enough up to this point. Don't forget that the point of intersection is always the origin. Okay, now look at the vector AB. We are moving from A to B. So what does it tell you? It means that the starting point is A, vector AB, moving from A to B. So the origin is A. We are moving from A to B. So this origin, I'll label it as the A. Okay, that's how you go about it. So in simple terms, always let the first letter indicate the origin. Use the first letter to indicate the origin. Okay, so A, B. So starting from A to B. So A is the first letter. So you bring the A as the origin. Okay. Then now let's go ahead and plot this component, which is the 3, 4, on the Cartesian plane. Okay. So now the 3 here is positive. Okay. So you come to the Cartesian plane here, and you know that because the 3 is positive and it's the S component, it will come at the positive S axis. Okay, so let's say my 3 will be somewhere here. Okay, so this is not drawn to scale. Okay, so just your imagination, you can just locate a point there. Okay, so this is my 3. And let's come to the 4 also. Okay, so let's say that the 4 is positive, so of course it will come at the positive Y axis. Okay, so let's say that the 4 will be somewhere here. So I have my 4 here. I hope you understand and you agree with me up to this point. Okay, so now let's go ahead and do a further explanation. Okay, so I've indicated my points there, which is 3 and 4. Okay, so now we are going to draw short dashes to locate where the 2 points meet. Okay, which is the 3 and the 4. Where do they meet? So I'm going to do a short dashes like this, or points. Okay, so you can see that the 3 and the 4, they meet at this point. Okay, I hope you can agree with me. Check it very well. The 3 and the 4, this is the point that they meet. Okay, they meet at this point. So I'm going to have this point to be my B. Okay, because we have vector AB moving from A to B. So I have my vector AB like this. Okay, so this is how to draw the component of the given vector on the Cartesian plane, and I hope the explanation is clear enough up to this point. Okay, so given any given vector, okay, you can draw it on the Cartesian plane using this approach. Okay, so now we are looking for the angle that the vector AB makes with the horizontal line. Okay, because that is now going to help us to be able to now calculate for the true bearing, okay, or the actual bearing of the vector AB. The question says we should find the direction of the vector AB. So finding the direction of the vector AB, it simply means that we are equally finding the bearing of the vector AB. Okay, so direction, as I've written, the direction or bearing of a vector, because it's in an attempt to find the direction of a vector which leads us to the bearing of the vector, because I've explained that the means to obtain that measure of angle is by bearing. Okay, so now this angle here, let me label it theta. We need to find it, okay, because when we are looking for the actual bearing of the vector AB, don't forget I've explained to you that when we are reading on the cardinal points, when it comes to bearing, we always start reading from the north, okay, in a clockwise direction, meaning that the actual direction of the vector AB, we need to start reading from the north up to the where the vector AB is being formed, up to the line. Okay, this is the line, the vector AB. I hope the explanation is clear enough up to this point. Now, this is the north. Okay, this is the north. And I've explained that anytime you want to get the bearing of anything, you start reading from where? the knot in the clockwise direction. So we want the direction or the bearing of the vector AB, which we've drawn here. So we need to start reading from the knot and we'll end on the line AB, which is the vector AB. You cannot exceed it. So to find the true bearing, we need to start reading from the knot up to this vector AB. You read from the knot up to where the vector is being formed. That's how you go about it. But we cannot find this angle until we've known the angle which is here, which is the theta. So we need to know the theta before we can proceed and find the angle which is here. Okay, that is why it is necessary for us to find the angle which is here. I hope the explanation is clear enough up to this point. So for us to find the angle which is being formed here, we are going to use a particular trig ratio. Okay, I've taught you this when we were handling right angle triangle. I taught you right angle triangle. We looked at the Pythagoras theorem, and when we were doing that, I went ahead to indicate the 3 trig ratios to you. Okay, so we are going to apply that knowledge here. Okay, but for the sake of those who don't have any knowledge on it, I'm still going to do a further explanation on it. Okay, so let's consider this triangle. Okay, I want us to consider this triangle. So I'm going to draw it here. So it's a right angle triangle. So I have my A here, I have my B here, and the angle theta is being formed here. Okay, so considering this right angle triangle, we want to look at that trig ratio that we are going to use to be able to find the angle theta, which is supposed to be here. Okay, so now this diagram, the slanted part, okay, which is always the longest part, is called the hypotenuse. Okay, so anytime you have a right angle triangle, the longest part of it, or the slanted part, okay, so normally the longest part of it is also the slanted part. Okay, so that is what we call the hypotenuse. Okay, so this is the hypotenuse. Let me indicate it. So we have this as the hypotenuse. Okay, then the side of the triangle which is opposite to the angle theta here. Okay, you can see that this side of the triangle is opposite to this angle theta here. We call it opposite. So this is the opposite. Okay, then the last side which forms the base of the triangle, okay, we call it the adjacent. Okay, so this is the adjacent. Okay, so let me represent this one by H. So the hypotenuse by H, the opposite by O, okay, and the adjacent by A. Okay, so let me put it here instead. Okay, so this is the labeling that you are supposed to know. Okay, so the slanted side or the longest side of a right angle triangle is called the hypotenuse. The part of it which is opposite to the angle theta, which is formed here, is called the opposite, and the third side, which normally forms the base of the triangle, is the adjacent. Okay, so now we are going to look at the 3 trig ratios, okay, which is sine, cos, and tan. Okay, we have sine, cos, and tan. Okay, so now when we want to get sine theta, okay, so sine theta, the sine of the angle here, the equation is sine theta equals to opposite over hypotenuse. Okay, if we want to get cos theta, the equation is cos theta equals to adjacent over hypotenuse. Okay, and the third one, if we want to get tan theta, let me write it somewhere here. So if you want to get tan theta, it is equal to opposite over adjacent. Okay, so these are the 3 trig ratios. Okay, so we have the sine, cos, and tan. So if you want to find sine theta is equal to opposite over hypotenuse. If you want to find cos theta is equal to adjacent over hypotenuse. If you want to find tan theta is equal to opposite over adjacent. And there's a short way to remember it, and I'm going to show you, and that is the SOHCAHTOA. Okay, so you can use that to easily remember the three trig ratios, okay, which is SOHCAHTOA. Let me write it somewhere so that you can see it. Okay, so let me write it here. We have the SOHCAHTOA. Okay, so you can use this one to easily remember them. Okay, now the S here refers to sine, the C here refers to cos, and the T here refers to tan. So if I want sine theta will be equal to the opposite over the hypotenuse. That's why I have this one here. So sine theta equals to opposite over hypotenuse. Okay, if I want the cos, okay, so the C refers to the cos theta will be equals to the adjacent over the hypotenuse. So you can see cos theta equals to adjacent over hypotenuse. Then if I want the tan, okay, so tan theta will be equal to opposite over adjacent. So tan theta equals to opposite over adjacent. So just use the SOHCAHTOA to help you to be able to remember the three trig ratios. And among these three trig ratios, there's one that we are going to use to be able to calculate for the angle theta, which is here. Okay, and that is the tan theta, which is this one. Tan theta is equal to the opposite over adjacent. And I'm going to explain to you why it's supposed to be tan theta is equal to the opposite over adjacent that we are using, and not any of the others. So now, let's start with the sine theta. You know that sine theta equals to the opposite over the hypotenuse. Now let's come to the diagram and see if we have the opposite and the hypotenuse there. Okay, let's check. This is the opposite. Okay, we have the opposite given. Now someone might be thinking that, oh, there's no value here at the opposite. Now let me show you. It's very simple. Can you see that from the origin up to this point is 4? So then it means that from here up to this point is also 4. Can you agree with me on that? Look at it. The origin up to here is 4. Then it means the distance from here up to here is also 4, because it's the same distance here which is being repeated here. So from the origin up to here is 4. Then it means that from here to here is also 4, because it's the same distance. So the distance from here to here is 4. Can you agree with me on that? Okay, I hope you understand. Then when I come here also, from here to here is 3. Okay, so the distance from here to here is 3. So let me put the 3 here so that you don't get confused. Okay, so from here to here is 3. Okay, so now I'm saying that when we come to the sine theta equals to the opposite over hypotenuse, you can see that the opposite we have it to be 4. Okay, but the hypotenuse, we don't know the hypotenuse. If you come to the diagram, this side is the hypotenuse. The slanted side is the hypotenuse, okay, which we don't know its value. So that's why we cannot use the sine theta, okay, because it's only the opposite that we know. We don't know the hypotenuse. Now let's come to the cos theta also. Cos theta equals adjacent over hypotenuse. Okay, let's check if we have it. The adjacent is the 3, we have it. Okay, this side is the adjacent. And the hypotenuse, this side, we don't have it. So it means we cannot use this trig ratio as well. Okay, which is the cos theta equals to the adjacent over the hypotenuse. We cannot use it. Okay, let's come to the tan theta, which is equal to opposite over adjacent. Now the opposite we have it, which is the 4. Here, this side of the triangle, which is the 4. The adjacent we have it, which is the 3. Okay, this side of the triangle. So it means we have to use the tan theta equals to the opposite over the adjacent. Okay, that's why among the three of them, it is the tan theta that we are going to use to be able to solve for the angle theta, which is here. I hope the explanation is clear enough up to this point. Okay, so you see that all the questions that you get on the direction or bearing of a vector, you'll be using the tan theta, because when you draw the diagram, you see that it will be the tan theta that you need to use. Okay, so let me clean this and let's go ahead and solve for the angle theta, which is here. We are going to use the tan theta. Okay, so let me clean this as well, and let me clean what I have here, and let's proceed to solve. Okay, so I have that my tan theta equals to opposite over adjacent. Okay, so I'm just going to input my values. So my tan theta will be equal to the opposite is 4. So 4 all over the adjacent is 3. So you bring your 3. Okay, from here to get your theta will be equal to tan inverse of 4 over 3. Okay, with this one, you don't go and say that you want to divide through by tan. No, you don't do it that way. So if you have a trig equation like this and you want to find the angle theta, what you do is that you repeat your theta, then this one will become tan inverse of the value which is here. So write your theta. How to write the tan inverse is that just write the tan and bring minus 1 on top of it. Okay, and that represents tan inverse. So theta equals to tan inverse of 4 over 3. And from here, you need to use your calculator to get the value. Okay, so let me use the calculator and let's look at the value. So tan inverse of 4 over 3. Okay, so just use your calculator to know the value of tan inverse of 4 over 3. And it's giving me 53.1301023.5 degrees. And of course, you don't have to write everything down. Okay, so just write it and leave it at 3 decimal place. Okay, so I'm going to do exactly that. Okay, so I have that my theta equals to 53.130 degrees. That is me leaving it at 3 decimal place. Okay, so this is the value of the angle theta. So now that we've gotten the angle theta, then it means we can proceed and find the actual bearing of the vector AB, or the actual direction of the vector AB. Okay, so now you remember that I said that anytime you are reading the bearing of anything, you always start from the north. Okay, very important. So if you want the actual direction of the vector AB, we need to start reading from the north and we'll end on the vector AB here. Okay, so always start from the north and you read till you reach where the vector line is being drawn. You cannot exceed the vector line. Okay, you always end on the vector line. Okay, that's why you have this here. So I'll start reading from the north and I'll end on this vector line. Okay, and that gives the actual direction of the vector AB. Okay, the angle theta here is not the actual direction. That was just to help us to be able to know the value which is supposed to be here. Okay, because without the value of the angle theta here, we cannot know here. That's why we needed to find the angle theta, so that it will help us to be able to find the angle which is here. Okay, that is we reading from the north up to the vector AB, which gives the actual direction of the vector AB. Okay, that's why it was necessary for us to find the angle theta here. Okay, but that is not the actual direction. I hope the explanation is clear enough up to this point. Okay, so the actual direction is when we read from the north and we end here. Okay, so since I don't know the angle here, I can just represent it by a variable, let's say s. So what that means is that the angle here, which is the S, plus the angle here, which is the theta, should give me 90 degrees. Then I'll proceed to solve for the value of S. Why should it give us 90 degrees? Because the whole of this quadrant is 90 degrees. Okay, the angle which is formed at this quadrant is 90 degrees. So the angle here plus the angle here should give us the 90 degrees which is formed at that quadrant. I hope the explanation is clear enough up to this point. Okay, so I'm going to do S plus theta equals to 90 degrees, and that becomes a simple linear equation to solve for the value of S, okay, which gives us the actual direction of the vector AB. Okay, so let's go ahead and do that. So I'm going to have that my S plus the angle theta should give me 90 degrees. Okay, and I know theta is 53.130 degrees, so I'll place it there. So my S plus 53.130 degrees should give me 90 degrees. And just make S the subject, so my S will be equal to 90 degrees minus 53.130 degrees. Okay, and your final answer will be, let's use the calculator to do it and see. Okay, so I have 90 minus 53.130, and that will give you 36.87 degrees. Okay, so I have my S equals to 36.87 degrees. And of course, I've explained to you that bearing should always be written in 3 figures. Okay, so meaning that we cannot leave it like this. We need to write it so that it becomes a 3 figure, So I've explained it to you that bearing needs to be written in 3 figures. So this I have to proceed and write it for it to be in 3 figures, but I'll run it to the nearest whole number. Okay, so running the 36.87 degrees to the nearest whole number is going to be 37 degrees, which I have to write it in 3 figures, okay, because it's a bearing. So my S will be equal to 0.37 degrees. Okay, so this is the final answer. Okay, so the direction of the vector AB is 37 degrees. Okay, so you write it down. So let me continue from here. So direction of the vector AB is equal to 0.37 degrees, and this is your final answer. I hope the explanation was clear enough and you understood it as well. Okay, so this is how to handle a question on finding the direction or bearing of a given vector. Okay, so this is the process that you need to go through. Okay, please don't forget to like the video and also share the video as well. And if you are watching for the first time, please do want to follow the page and also subscribe to my YouTube channel as well. Okay, I will see you again in another video whilst we solve more examples on this. Bye bye.